So this is about L8148J Aquastat that controls millivolt gas valve. So that's for millivolt circuits. If you have gas valve, which is millivolt, and you know that by you having a thermopile, so thermopile generates about 750 millivolts and supplies to the gas valve. This gas valve probably requires about 200 millivolts. I'm just saying a number. It might be a little less, might be a little more. It does not matter. But we know that the gas valve has no power except thermopile. Thermopile is the only power that this gas valve works off of. And since we don't need 24 volts, all we really need is just a thermostat basically and Aquastat in series, right? Nothing else. Because let's say there is another gas valve here, that's the old one. It's 24 volt gas valve, right? This one requires 24 volt because if you connect thermopile, it will not work. So let's set this aside. Forget about the 24 volt gas valves for now. We talk about millivolt gas valves. So that works. It requires only 750 millivolt, and probably the valve drops. There's a voltage drop, and it probably works off 200 millivolt. We have different aquastats here for just for illustration purposes. So there's a L8148A. This is for burner circuits like oil boilers. Let's say next one is 8148E. This is for gas boilers, for example. And let's say L8124C. This is for oil boilers or possibly gas boilers that have domestic hot water hooked up to it. But let's set these aquastats aside as well. I just want to concentrate on this specific aquastat here. It says it's for burner circuit, 24 volts, or can be millivolt. Okay, let's do a quick overview. This aquastat is actually, it has three terminals, B1, B2, B3. If you connect B1 and B3, if you wire B1 and B3 to the burner or gas valve in this case, then we will have 24 volts here. But if you use B1 and B2, it can be connected to millivolt gas valve and control the millivolt gas valve. This video is not going to be long. I'm going to keep it very short. But what I want to say is, let's say I'm going to connect the aquastat to the power, and we will get 24 volts between B1 and B3. Okay, that's 24 volts because we have TP and Z connected, jumper together. See this red jumper right here? Let me remove this red jumper because this is specifically for 24 volts. Once I remove the jumper, now this is not for 24 volts anymore. This becomes actually millivolt aquastat. And let's plug this in again, and we'll see that we don't have any more 24 volts because it's a dual rated aquastat. It's both for 24 volts, so we don't have any 24 volts. But now this is for millivolt circuit. Now, millivolt, remember, does not need any power from the aquastat. It does not need anything from here. This is simply an aquastat in series. Now, B1 and B2 will have continuity because when there is a call for heat, in this case I'm just using jumper instead of thermostat, it's just continuity here, nothing else. And let's say if I remove this, I will not have continuity anymore. Okay, basically when thermostat calls for heat, B1 and B2 get connected to each other, just have continuity, and then it supplies power to the gas valve to open. Now, there's one more thing that was confusing, and the question came last week about how this really worked, because the technician was thinking that gas valve needed power from the Aquastat. That's absolutely not the case, because gas valve does not need any power from anything except thermopile. Thermopile provides power between here and here, and that pulls down this pilot solenoid. And thermopile also provides power to the other solenoid, which is the second one, to open the gas valve. And it's enough power generated by thermopile to ensure that pilot solenoid pulls down and stays there, stays open as far as the pilot is there, and enough power for other solenoid to open the gas valve and allow the main gas to flow to the burners. So the bottom line here is that these gas valves, the millivolt gas valves, do not require any outside power of any kind except thermopile. Thermopile provides enough power for both solenoids to be, one to be open and the other to be open as well, just to be pulled down. Now, what Aquastat does is simply, Aquastat is in series between here and here. Okay, that's all it is, because when temperature is reached, gas valve is not needed anymore, so the Aquastat will cut power to the gas valve. So I wish I had this wired, but if I come across this in real situation, I'll shoot the video so that the concept will make sense. This video is about the concept, and just do your own reading, check the manual, and do what you have to do in your case. But this is just a concept, how this is supposed to work and how it works. And in this case, B1 and B2 is just an end switch. Let's say it's just a switch, because once there is call for heat and the boiler is not satisfied, power is not satisfied, I mean the heat, the temperature is not satisfied, then these switches are connected to each other. It's like jumper together, because we need the gas valve to run to make sure the water temperature goes up. But once the water temperature is reached, the contact here breaks. That way the gas valve, main valve, will not get any more power and it will drop. And that way only pilot will stay and the burners will lose gas, and that shuts the gas off. So it's just a general video, just a concept, how millivolt gas valves work in conjunction with Aquastat. In this case, this is L8148J. J is specifically for millivolt. And none of these Aquastats actually say millivolt. They say just burner. This is the same burner circuit, but none of them says that it's rated for millivolt. Only J in this case is rated for millivolt. Just be aware of this, because you can't use any of these Aquastats instead of that Aquastat, because that's not cross-reference anyway. But yeah, all right, I hope this was helpful, informational, and please like and subscribe if you'd like to see more content. And once the videos be available, you will see the notifications so you don't miss the videos. Thanks for watching.